Thank you for joining us in our webinar. We'll begin in 1 minute. We'll begin the presentation in 30 seconds. All right, let's go ahead and get started. Thank you for joining us on our webinar, Discover Spectro Cloud Palette, the modern Kubernetes management platform. We'll do a deep dive into the Palette platform, targeting specifically the enterprise's use cases of deploying and managing Kubernetes clusters at scale. My name is Saad Malik, and I'm the CTO for Spectro Cloud. I'll also be the host for the webinar. If you have any questions, feel free to post them using the webinar's questions section, and we'll try to answer these questions as part of the presentation. Before we get to the demo, I'm going to spend just a couple of minutes on slides talking about Palette and its capabilities. So Palette is Spectro Cloud's modern Kubernetes management platform, which provides comprehensive day zero, day one, and day two lifecycle management of all your Kubernetes clusters. This is done so across any environment, whether you are running clusters in clouds, data centers, bare metal, or edge. So what problems does Spectro Cloud Palette try to solve? As organizations begin deploying Kubernetes in production, they realize there are additional complexities which aren't addressed in either traditional tools or do-it-yourself approaches. When more and more containerized workloads are being onboarded, there is an increasing amount of clusters under management, whether this is to help limit the blast radius, lower application latency times, or helping address unique requirements for tenancy. And being able to support these clusters, not just in one environment, but across all environments, from public clouds, private clouds, data centers, etc. And finally, to be able to take advantage of the 1,800 plus different integrations available in the cloud native ecosystem. What this translates into, our customers want a platform to support any number of clusters, ranging from hundreds to tens of thousands, especially when deploying into an edge environment. They want a single management environment that can work exactly the same, whether it's in cloud, data center, or edge, and also get complete lifecycle management across their entire stack, everything from the operating system to the Kubernetes and their applications. And all of this with comprehensive enterprise cloud security and governance for the platform, the clusters, and the applications. All of these can be attributed to operating Kubernetes in production with scale. For Kubernetes management, scale takes on a different definition. It's the ability to deploy at scale, manage at scale, innovate at scale, and finally provide security and governance at scale. Pulling all of this together is what Spectro Cloud has provided with its platform, Palette. Palette provides all of these different attributes and capabilities to deploy, manage, and secure at scale. When it comes to deployment, Palette's unique decentralized architecture can support tens of thousands of unique clusters from the same management plane, even working across environments where there are no cloud endpoints or infrastructures like edge. With manage at scale, the ability to deploy beyond the core stack of just the OS and Kubernetes and bring in innovation across logging, monitoring, security, and dozens of other integrations typically found in a cluster. Palette ensures that all of these components continue to work together and even prevents configuration drifts with a high frequency reconciliation loop, which auto heals both the infrastructure and the applications. Third is the ability to innovate at scale from providing support for any Kubernetes distribution, whether cloud managed Kubernetes or otherwise. And for developers, a really innovative developer workbench, which helps developer focusing on developing applications without having to understand the Kubernetes constructs like deployments, pods, and etc. Also, as part of the developer-related functionality, Palette provides common application services like databases, message buses, and so on, which can be quickly modeled and deployed into any environment. And lastly, security and governance capabilities as built in, with out-of-the-box security hardened images and configurations, and enterprise functionality related to backup restore, RBAC, and a number of different scans for security and penetrations. So Palette is made available in two versions, the Palette Enterprise and Palette Edge. Palette Enterprise is traditionally used for use cases such as Kubernetes as a service, where platform engineering teams can provide Kubernetes clusters for the developers, multi-cluster fleet management that allows enterprise teams to manage many different distributions of clusters, existing and new, and the developer workbench to allow application developers to gain full productivity developing their cloud native applications. And with Palette Edge, we provide a very unique capabilities that deal with the nuances at the edge, such as zero downtime upgrades to having no IT resources, and also providing immutability and tamper-proof deployments. Okay, that's done with the slides. Let's go into the demo. For this presentation and the demo, I'll focus primarily on the Palette Enterprise capabilities, and in future webinars, we'll cover more of the Palette developer experience and the developer workbench, as well as the Palette Edge capabilities. All right, let's go ahead and get the demo started. So Spectro Cloud Palette is provided in three different deployment models. We offer it as a multi-tenant SaaS, where we operate and run the entire management platform on behalf of our customers. We do also offer single tenant SaaS, where we still operate and manage the entire system, but dedicated to only a single customer. And then we also have the option for installing the entire system behind your on premise or behind your own VPCs. It's offered as a Helm chart. As I log into the platform, you'll notice that we authenticate with both OpenID Connect and SAML based IDPs. We not only use this for authentication, but also for authorization purposes. As I log into Spectro Cloud Palette, I get logged into a concept called a project. Projects is how we provide isolation between different sets of users and the resources that exist in those projects. The resources here would exist are Kubernetes clusters, blueprint or templates that we call cluster profiles, and other settings as well. If I switch over to the tenant admin view, we can very quickly at a glance get visibility in terms of all the resources running across the entire tenant, from all the various clusters down to the infrastructure cost running across different projects, as well as the consumption of the CPU and memory across all the resources. If I switch back to the default project, again, this is now we're limiting the resources based on the ones existing in the default project. And we also are able to, at a quick glance, get visibility in terms of all of the cloud costs down to the CPU and memory consumptions within those clusters. The heart of Spectro Cloud is a concept called cluster profiles. And you can think of it like a blueprint or template that describes the entire infrastructure of everything running in a cluster. It captures everything from the operating system to the Kubernetes versions, networking and storage. These are what we call the core layers, and anything that sits on top of it, from the load balancers, service mesh, ingress, logging, monitoring, and more, are what we call add-on layers. As you notice, Spectro Cloud is able to do full stack management, where we can manage the entire stack of all of the clusters. Not only is this blueprint used for provisioning, but it's also used for applying day two updates. Any changes that you do to the cluster profile are automatically reflected onto the clusters that were provisioned from this profile. It's a very easy way to drive consistency into all of your environments. Let's go ahead and provision a new cluster profile that will be used to provision new clusters. If I go back to the profiles page, select add cluster profile, give it a name. Here we can say we can specify EKS demo 5. I can specify the type of the cluster profile. A full cluster profile essentially captures the core layers and the add-on layers, but I do have the option of specifying keep the infrastructure layers and the add-ons separate. A good use case for that would be if I have multi-environment clusters, where certain clusters are being provisioned on perhaps Amazon via the EKS management plane, and others could be on-prem, perhaps on VMware. You may still have some configurations that needs to be consistent regardless of the cluster environment. For example, I may want to choose to capture all of my monitoring configuration for Prometheus and my alert rules separately in a separate add-on profile that could be applied to any cluster technology regardless of the environment. For this demo, we'll pick the full cluster profile. We can add tags like demo one. These tags are not only used for filtering inside of our platform, but these tags are also pushed down to the underlying cloud technologies. So in this case, any of the EKS worker pools and all the resources that are provisioned would have the demo one tag added. From the cloud type page, I can specify, am I provisioning a managed Kubernetes provider like AKS, EKS, GKE, or am I provisioning a VM-based Kubernetes? For the public clouds, we offer both the managed Kubernetes selections as well as the VM-based Kubernetes options as well. Let's pick EKS and then select next. Now from the public repository, we can select different type of images and operating systems. For this one, we'll pick Amazon EKS. And then for the next layer up for Kubernetes, let's go ahead and select the latest version of Kubernetes 1.24. All the default configurations has been security hardened, but if there's any specific configurations that you need to do, perhaps enable additional logging for EKS, those are changes you can do directly in this manifest layer here. We also allow presets that make it very easy to enable and disable configurations in bulk without having to go into the manifest. For the next layer, let's go ahead and pick the CNI. We have the option between the Amazon provided VPC CNI or picking perhaps Calico. Let's pick Amazon VPC CNI. And for the storage layer, we have an option of either configuring external storage solutions like Portworx, or if I want to choose something native, I can pick the Amazon EBS CSI. Now that we're done configuring the core layers, we can add any of the additional add-on layers. If I select add new pack, we support over 50 plus different integrations in our public repository. Each of these integrations, whether it's from logging, monitoring, security, and more, have been pre-validated and pre-tested across every version of Kubernetes that we provide. In addition, we capture additional metadata in terms of the CPU and memory and storage requirements, so that when you are provisioning clusters with certain integrations, there are pre-flight checks that ensure that you have all the right configurations to deploy the workloads you've selected. Furthermore, if for most of the integrations, we do capture additional metadata, which can validate things like are certain required fields or attributes needed. For the Prometheus operator at version 44, there is a password that is a required field. So one, we're able to mask the password, and two, the validation errors are also gone. I can very easily add additional type of integrations. Perhaps I want to add an ingress of type Nginx at its latest version. I can also add perhaps a service mesh into this cluster profile. If there's certain integrations that are not available in a public repository, it's very easy for customers to be able to bring in their own set of integrations in a private repositories. There is also support for bringing in your applications and integrations via Helm charts. Both OCI Helm chart registries are supported, as well as Helm v3 registries. Now that we're done with modeling the cluster profile, we can go ahead and save it. One more thing to notice is this API button. You can see the exact request payload that the UI is using to hit the Spectro Cloud Palette backend. All the APIs for Palette are completely open and documented at docs.spectrocloud.com. And we also do publish the Swagger and Open API specifications if you want to consume APIs directly. Let's go ahead and click on Finish Configuration to create the cluster profile. I can then switch to the Clusters tab, which will show all of the clusters running in this default project. In my environment, I have clusters running across MAS, which is a bare metal management interface for data centers. I have clusters running in Azure, in Google, VMware, OpenShift, and others. Whether you provision these clusters using Spectro Cloud Palette or import existing clusters like Rancher, OpenShift, and others, we can provide the same level of visibility and health and metrics, as well as management capabilities to add additional integrations and run day two operations like backup, restore, and others. Before we provision a new EKS cluster, let me quickly show you the project settings page where I can define my cloud accounts for different cloud endpoints, whether it is for my public clouds like Amazon, Google, Azure, or my data centers or edge environments. So for Amazon, we can select Add Amazon Account, and then we have the option of either specifying the credential base, access key, secret key, or the more preferred way of is specifying an assume role, ARN. All the needed permissions and policies are specified on the right-hand side. Once you've added a cloud account, you can go ahead and go back to the clusters page. And then from here, select Add New Cluster. Select Deploy New Cluster, and then select Amazon from the selection. Select Start AWS Configuration. I can say EKS Demo 5, specify the cloud account. And here I will pick AWS EKS. And then we have the choice, are we provisioning VM-based Kubernetes using EC2, or are we provisioning a managed Kubernetes? So let's pick managed Kubernetes at EKS Demo 5. Select Next. I have the option of making any customization or overrides. Perhaps I want slightly different configuration for my Nginx layers or my service mesh layers. One thing that we do is even though the cluster profile designates the integrations and the configuration for each of the clusters, any overrides that you specify for a cluster are kept with the cluster. If you were to go back to the cluster profile and make any modifications, any changes that you've done in a cluster specific local would still be maintained going forward. I can add additional add-on layers. Perhaps here I would like to add a security layer, right? And I can take a look that security is bringing in Fairwinds and RBAC. I may also perhaps want to add a monitoring layer that perhaps add in additional monitoring capabilities like the dashboard and Prometheus. From the next page for EKS, we have two modes of provisioning. We can do what's called static placement, where we will place the EKS infrastructure into existing VPCs and or into existing infrastructure like the VPCs and subnets. Or you could choose to do dynamic placement, where for this cluster, we will provision a new VPCs and related infrastructure with it. For the region, we'll select US West 2. For SSH key, we can pick default. I can choose whether my APS server is exposed or is it private, and additionally enable other configurations like encryption. For the worker pools, I can specify I want to have 3 nodes in my default worker pool. Are my worker nodes coming as on demand? Great. They could be a GPU based workloads. They could also be something smaller like a T3 extra large. We do also support spot based instances so that you can maximize your cost savings for workloads that can tolerate some downtimes. If you do have workloads that are very ephemeral in nature, you may also choose to add Fargate profiles, which will essentially provision dedicated nodes for every single pod, where you have workloads that are very sporadic in nature and ephemeral. More than provisioning the cluster, there's a lot that we do for day two management. Everything from OS patching, to being able to run scans for security and penetration in other layers. Most of these day two capabilities will come back to after we're done provisioning this cluster. I'll click on validate, make sure everything looks good, and then we'll click on finish deployment. Deployment itself will take around 15 to 20 minutes, depending on the number of nodes I've added, as well as the profiles that have been selected and applications to be installed. Now, we can either wait for this cluster to finish provisioning or I can jump into an existing cluster. But before I do that, let me wrap up the day one provisioning by showing also an on-prem version of a cluster, perhaps running on VMware. So similarly, if I go into the project settings, you'll notice that I have a VMware Cloud account that's been added. One thing to also notice is if you deploy the palette management platform in an on-prem version, then the palette management platform has direct connectivity to interface with your vCenter. However, if you are running our public SaaS version or a dedicated SaaS version of the palette, we have a component called a private cloud gateway that acts like a proxy between your data center and our SaaS instance. So in this case, you don't have to open up any vCenter ports into your environment. From here, let's go ahead and go back to the clusters view. I can select add new cluster, select deploy new cluster. And from here, we can select VMware, select start VMware configuration, specify the name, VMware demo 6, specify the cloud account, and then select next. Now we are filtering based on all the cluster profiles that target VMware. So let's pick this prod VMware as an example. Again, if any customizations have to happen, I can do those overrides here. And now the placement properties for VMware are slightly different than for Amazon. Whereas for Amazon, we were specifying the VPCs and regions and availability zones. On VMware, you specify what is a data center to connect into, what is a deployment folder, which template should I be using? Is a static IP based on IPAM, or are we using DHCP, SSH keys, etc.? Now, because we are doing a VM-based Kubernetes, we do also have to provision a master and control plane nodes. If I want to have a small cluster, I can choose to remove the worker pool and allow the masters to also act as workers. Or if I have a large clusters, perhaps some with GPU capabilities and other hardware accelerated nodes, I can have multiple worker pools that I can add. For now, let's go ahead and stick to a single master pool and a single worker pool. Let's go ahead and specify 3 masters. I can specify my CPU, memory, and disk, and then I will specify which compute cluster is this master's coming from, which resource pool, which data store, which network. Because I'm provisioning 3 masters, I do want them to be distributed across multiple fault domains. And so for VMware, that would essentially mean adding another compute cluster. And then for the data store selection and the network. And similarly for my third fault domain, I can select compute clusters 3, my resource pool, my data store, and my network. For the worker pool configuration, I can specify whether to enable auto scaling or not, how many workers I want to add, and then I can specify additional taints if I need to. And then what we can do is perhaps copy the configuration from the master pool, but maybe let's bump up the number of CPUs to 4 and use 8 GB of memory for the workers. If everything looks good, I can select next. One thing to also notice, as I'm selecting different CPUs and memories and instance types, the estimated rate changes. For public clouds, the estimated rate is based on us pulling on a nightly basis what the instance types cost are for Amazon, Google, Azure. And then based on the instance type that you select, we're able to make an estimated rate. For private clouds like OpenStack, VMware, and MAS, the administrator is able to specify what is one CPU core cost, as well as what is 1 GB of memory cost. Similarly to the EKS example, the day two capabilities from being able to run OS patching to running scans and backups, all the same capabilities are provided regardless your clusters are provisioned in public clouds, private clouds, data centers, edge, or bare metal. Select validate, make sure everything looks good, and then click on finish configuration. It's really as easy as going through a very simple day zero workflow of specifying your cluster profiles. And then from there, using our very simple UI, day one provision clusters in any environment. Okay, so from here, let's jump into an existing cluster to show what are some of the day two capabilities. We can go into this VMware prod one cluster, and you'll notice that we capture details like the CPU and memory at the infrastructure level, as well as the consumption within the cluster. We can see that the cluster is healthy in a running state, running a specific version of Kubernetes. Any application services that are exposed, these could be load balancer type services, node ports, or ingresses, are directly visible from here. I can connect to the Kubernetes API server using a web-based kubectl terminal, or if I need to download a kubeconfig to my workstation, and then whether I use kubectl CLI or any of the helper CLIs like Kden's to connect to it. If I switch over to the profile tab, these are all of the profiles attached to this cluster, from monitoring layers to my infrastructure layers. If I need to make any customizations, I can do them here. If I select the workloads tab, these are all the different resources that are running in the cluster. Everything from the different namespaces to the pods, deployments, etc. I can even drill down into a pod and get more information about it, how it's running. Now, jumping into the nodes tab, this is where you can see the nodes that are running for this cluster. I can scale up and down my master nodes. I can scale up and down my worker nodes. Perhaps I can say, for part of my day two operation, I want to scale my GPU node pools from one nodes to two nodes. You'll get a confirmation that you're doing updates. We are also able to change the placement properties and configuration, perhaps adding additional fault domains for the GPU nodes to be added across. If you are trying to bring in new type of VM configuration workloads, you can add a new pool, specify, the compute clusters, the configuration and resource constraints for this additional pool. On the events page, we can see all of the event logs for how the orchestration of the cluster and day2 operations are happening. And then on the scan page, this is where we can see a number of different type of scans. Everything from configuration scans that that you can be scheduled to run on a nightly basis. And these configuration scans essentially runs a tool called Kubench to verify the configuration for your Kubernetes clusters is up to spec. We can also download these different config scans as a PDF or a CSV as needed. We additionally support testing with a tool called KubeHunter that does penetration scanning into your cluster, both inside the cluster as well as from an external pen test perspective. We can run Sonobuoy scans that is able to verify that the clusters are conformant. Some of our customers like to run these scans before every major update to Kubernetes. And then the latest scan that we just added is something called software SBOM scanning, where we're able to scan all of the different pods running in all namespaces for the dependencies, and additionally also show if there are any vulnerabilities. And finally, under the backups tab, I'm able to see all of the backups in this cluster, as well as trigger an ad hoc backup. So maybe let's click on add create backup, specify test two, specify the backup location, what is the retention period for the backup, whether to include all the persistent volumes or not, as well as the cluster resources, include all the namespaces for backup, or maybe only limit it to a specific namespace like application namespace default. If I select create backup, this will trigger the backup operation. Even though we support ad hoc operations for triggering backups in any of the scans, all of these can also be configured to run on a policy. For instance, if I click on the settings and click on the cluster settings page, I can click on the machine management tab and I can specify how often do I want the operating systems of the worker nodes and control plane nodes to be updated. That could be done on a weekly basis or on a custom cron schedule as I need to. I can also specify things like what is my actual scan policies, whether to scan the Cube-Edge, Kube-Hunter, Sonoboy on a nightly basis or weekly basis as needed. Same thing for my different backup schedules. I can choose to back it up on a daily basis and to choose to back up all namespaces as needed. I'll get back to the RBAC virtual clusters and location settings shortly. So continuing with the day two operations, let's take a look at how easy we make upgrading Kubernetes in this cluster. Switch to the Overview tab and take a look at the infrastructure profile used to govern this cluster. For the VMware Prod 1 cluster, it is the Prod VMware cluster profile. Switch back to the Profiles tab, search for that profile Prod VMware, select it, and then I can choose the version of the cluster profile that I want to modify or create a new version. In this case, we can leave it at the version 1.1.1. I can go to the Kubernetes layer and I can specify perhaps a newer version of Kubernetes. I want to go from 1.23.9 to maybe 1.24.10. If there's any certain configuration that is different, I can see those overrides directly here. I can select confirm and then click on confirm updates and then save changes. Notice how the networking CNI layer is doing a pre-flight check that some of the configuration isn't compatible. If I take a look at that, this Calico version is not compatible with the version of Kubernetes that we selected. Let's go ahead and fix this. Go into the networking layer. And then from the version, we can select a newer version of Calico, 3.24.5. See if there's any additional configuration which needs to be done, confirm the changes, and click on save. Any changes that you do to clusters or cluster profiles or other resources are automatically logged in the audit logs. We can also add additional notes so that operators can see when a change was made, why, and by whom. Supporting new versions of Calico and Kubernetes. Click on save. I can select the audit logs tab to see the actual change done by me and the exact message that I also specified there. If I switch to my clusters view, you'll notice that my VMware Prod 1 cluster, as well as my VMware Prod 2 clusters, have an update available. I can go into the cluster and then click on update available to see exactly what's changing. Whether it's your Kubernetes layers being changed, any new application layers being introduced, the administrator, before they apply the change, has full visibility to see exactly what's changed. I can select confirm updates, and then within minutes now, a new version of this Kubernetes will be rolled out. The way the upgrade happens for VM-based Kubernetes is through a rolling upgrade process. A new VM with a new version of the Kubernetes version is going to be launched. If it's able to join the master pool successfully, then an older version of the node is going to become decommissioned. And a similar rolling process happens for the remaining control plane nodes, and then it'll roll through all of the additional worker pools. Another important aspect of running Kubernetes in production is having resiliency when it comes to your infrastructure and applications. If the system detects a config drift between the desired state of the infrastructure and the actual state, then the platform will try to reconcile it as quickly as possible. For example, let's go into the VMware Prod 2 cluster and take a look at the configuration. So for this VMware Prod 2, I have a single master node with 2 machine pools for my worker nodes, 2 for my worker basic, and 2 for test basic. What we will do is go into VMware, and from here, I'm going to go ahead and go into the VMware 2 cluster, and we're going to maybe power one of these guys off. So we're going to power off the test basic worker node, and then we're going to go ahead and delete it once it's powered off. At this point in time, the actual state of the cluster is only 4 nodes, whereas it should have been 5 nodes. The system will automatically detect that one of the nodes is either no longer healthy or no longer available. And through our reconciliation, our system will automatically detect and launch a new node to recover the system. Here you can see that a new node is now being cloned, and this will automatically recover the system to the desired state as specified. Switching back to the Palette console, similarly, if any of the application configuration has changed, for instance, if I had accidentally deleted any of these integrations or misconfigured manually any of these configurations on the cluster, our Palette agent that runs inside of the cluster will detect the config drift and revert the changes back to what the desired state that's specified in the profile. Switching gears towards role-based access control, Palette has a unique feature called workspaces. Workspaces are logical namespaces that are shared across one or more clusters. This is typically useful in larger multi-tenant environments where a platform engineering team dedicates one or two namespaces for each team, but they still want to provide visibility. In this example, I have a Pathfinder workspace that is defining two namespaces, Pathfinder DevTest and Pathfinder Fraud, running across 5 different clusters. We have a very similar dashboard where we can see across these namespaces and across different clusters, all the different resources that are running. If I select the settings page, here I can define my cluster mappings, which clusters belong or part of this workspace. I can define my cluster role bindings. What are the cluster role bindings to which groups that are Palette groups or coming from the IDP? And then I can also specify my namespaces, my Pathfinder DevTest namespace and Pathfinder Prod, any resource quotas that I want to specify either across the entire workspace or allocated specifically for each namespace. And similarly, specify if there are any role bindings across different groups as needed. Now, these are the RBAC permissions that are inside of a cluster that are based on role bindings and cluster role bindings. We can also map different role-based access control for different users and different projects. If I switch to the tenant admin view, right, and I switch to the projects view, these are all the other projects which exist within my tenant. As an admin user, I get full visibility, but I can also specify governance limits to limit the amount of CPUs and spend each team or each project may have. If I select the clusters list, these are all the clusters that are running in my entire environment. And then if I select the roles page, these are the out of the box roles for the platform. If I select the project admin, there's a very granular set of permissions that can be applied. And you can use these out of the box roles as is, or if needed, create your own custom roles for either tenant level or project level. Users and teams is where I do all my role-based access control mappings for individual users or team-based. For small POC environments, you can manually create the users and assign them to specific projects and teams as needed. But most enterprises do use an external identity provider like Okta or Azure AD, and groups are automatically synchronized into Spectro Cloud Palette so that your IDP becomes a single source of truth for defining not only the set of users for authentication, but what permissions each group or entity has. Finally, under the tenant settings under cloud rates, I can specify my overrides for my private clouds. What does one core of CPU cost me? What does 1 GB of memory cost me for my private instances? I can register additional registries, whether they are Ham v3 registries, OCI registries, or even Spectro Cloud's Palette version called pack registries that provide additional metadata. There are many additional capabilities from specifying your private cloud gateways for connectivity between SaaS and private data centers, specifying additional SSH keys, setting up single sign-on. I will leave these for a demo for another day. Finally, let's take a look at the API for Spectro Cloud. You can open up a window, go to docs.spectrocloud.com, select the API tab button, and here you have full visibility. You can see all the APIs exposed on Palette. For instance, I can pick the Clouds APIs or pick perhaps Clusters APIs and see all the different operations and samples needed to provision and manage clusters. We do also offer a very robust Terraform provider that is used by all of our customers to provision and manage concepts like cluster profiles and Kubernetes clusters and so forth. As an example of how this automation would look like, there is a GitOps Picard repo sample that is publicly available. And from here, we can see the object model for defining a cluster profile. Here, we are defining the various layers that go into the cluster profile, like your ingress and your metal LB load balancers and your service mesh like Istio. And then to define an actual cluster, you specify, cluster VMware prod 1, and the properties would be your cluster profile associations, cloud account, and under the cloud config, there are specific placement properties like a data center folder, and similarly, the placement properties for a machine pool that are specific to VMware. As an example, if I was to take a look at a cluster for Azure, or perhaps for GCP, right? You'll notice that the configuration for the cluster profiles cloud account ID is very similar. The only difference would be in the placement properties. In the case for GCP, you're selecting which project and which region and which instance type to use, as opposed to hard coding the CPU memory and storage for VMware. With an approach like Spectro Cloud Palette, we abstract the complexity of using Terraform to directly interface with the different cloud providers. The only interaction for the Terraform providers is the Spectro Cloud resources, and Spectro Cloud will handle the provisioning of both the infrastructure as well as the cluster components, regardless if it's on the public cloud, private cloud, data centers, or edge environments. Well, that wraps up the demo and presentation on Palette. I hope you all enjoyed it. If you have any questions, please do ask in the questions section below. If you're interested in learning more about Palette or interested in trying a free demo, please go to spectrocloud.com and sign up. Thank you everyone for joining, and I'll stick around for a few minutes to answer any additional questions.